Over the past 20 years, there has been a quiet revolution where electronics has invaded every aspect of our lives. It is now difficult to remember how we communicated before there were mobile phones, how we listened to music before the advent of iPods and MP3 players, and how we found our way about without GPS satellite communication. At the heart of all these complex electronic systems is a small computing device known as a microcontroller. I'm Andy Gibson. I'm head of the School of Electrical and Electronic Engineering here at the University of Manchester. All universities that are world leading have a big research component in terms of the work they do. The University of Manchester is leading in terms of the field of engineering. For example, in electrical engineering, we were second in terms of research quality for the research assessment exercise.
For my labs, I use a teaching platform from one of our industrial partners, National Instruments, and it's called NI Elvis. What this is hardware and software, and so what we get the students to do is design a circuit in software, and then they simulate the output response. Then they come into the lab and they build the same circuit on this prototype circuit board. They measure the output response using benchtop instruments, and they compare the measured and the simulated responses. My module tries to pull together theoretical aspects of electronic circuit design with practical implementation.
It's not just research which drives us here in Manchester in electrical engineering, it's also teaching, and we are dedicated to providing a world-class education for our students.
Electrical circuits is a very important topic because it gives you the tool to analyze all the applications that you're going to study in electrical and electronic engineering. You need electrical circuit analysis to find out how one of these microchip functions, or how you might design one of these. Or you can use it to find out how to optimize how this magnificent little spider here functions. On a bigger scale, electric circuit analysis is also useful for optimizing electric vehicles or to understand how the national grid operates. So its beauty is that it's a single theory that works from nanometers all the way to hundreds of kilometers.
The project we did in the second year is called Embedded Systems Project. Our task was to construct a buggy-looking robot which must have been able to navigate itself around the given track. The project was split in two parts where we had to build the mechanical body of a robot and then design and implement the sensing system which will control the motion of the robot and its navigation around the track.
So we're standing in the High Voltage Lab, which is part of the National Grid Power Systems Research Centre, which is the second largest in the UK and the largest of any UK university. And behind me you can see a 2 million volt generator. We bring third year students in here, and the third year students use it to actually test an overhead line that they design as part of the course to get that practical understanding of power system equipment. We also have third year students and fourth years who may use this as part of their final year projects. So they will set up an experiment and they can use anything up to 2 million volts as part of their research activity.
This is a typical third-year project done by students on face recognition using a webcam and build software to interact with the webcam. So the webcam will track, detect faces and recognize registered faces. And for example, if I pop my head in, it detect me and recognize me and also track me. These students did quite well and got third-year project prize and also being shortlisted for the National Settle Award. Also, this project has attracted attention of UMIP, the University of Manchester commercialization arm, to see if it's a possibility to commercialize this product.
The school has really strong links with industry, and that's evidenced by this lab. It's funded by industry, and as part of it we have people who come to the school who see the research that we do, who also understand the quality of our teaching.
We're here to promote the Power Academy. Power Academy gets students, while they're still at university, into working with industry and building those sort of ties early on.
We're here at the Power Academy. It's got some really awesome companies involved with it, the kind of companies we want to be involved with.
I'm here representing Rolls-Royce at the Power Academy to promote Rolls-Royce as a means of getting into the engineering business.
I'm representing ABB. I'm here from the high voltage, the power side. I've come on the basis that I've come through this process of the Power Academy and then went into working for ABB, so I've got experience to speak to the people here.
I've been with the Power Academy for 2 years now, so I know a lot of people with Rolls-Royce. My placements have given me different areas of the company that have got lots of experience with that.
Once they've got a Power Academy sponsorship, they're set up, they don't need to go looking for anything else.
Undoubtedly, these projects leave our students in a very good position with respect to progressing in their careers.
The electrical engineering course is quite broad. You don't specialise in anything. You try and learn as much as you can, really. You can learn from the high voltage, high power sort of side of the course, or the low power microcontrollers, communications, microwave communication subject areas. You can have industrial experience as well in between your second and third years, or your third and fourth years. That's accredited as well, and it's an IET accredited course as well, so you can get a chartered status if you're doing masters as well. For my third year individual projects, I've arranged for the school to allow me to have a project to do with the former student car. This year it's going to be a solid state power control module.
What makes us different with respect to how we do our research is that we try to bring our research into our undergraduate programmes. We may do an energy or e-agri type project in software exercises, or in terms of final year projects, or in team projects. This year we have a team project in the area of the electric vehicle.
We have to design and build a single-seater racing car in a year from scratch. The team this year consists of about 20 people from all sorts of disciplines. We have electrical and mechanical, aerospace.
It's an international competition which is held at Silverstone every year. So you get teams from all over the world which are involved. We made it to the competition and we managed to finish in 23rd out of the 80 teams which competed.
In order to enhance communications between staff and student in our school, we have a staff-student liaison committee which is very active, and we also have an electrical engineering society, and we believe that helps to enhance the community feeling within the school. So undoubtedly, electrical technology is going to be incredibly important in the future in terms of solving the global problems such as energy, food security and climate change. Electrical technology has to impact in all these areas.
In future, we may be less reliant on gas, we'll need more electricity, we'll have electric cars, and for that reason the school has an energy research theme. The engineers of today will need to produce solutions that will give the world a way of producing and using energy while generating less carbon dioxide, so preserving the planet. There's a big electrical revolution today, so the students can really be part of that.
We firmly believe that choosing to study electrical engineering at Manchester will be one of the wisest decisions that you ever make. The profession of electrical engineering offers you many opportunities in terms of where you want to work and how you want to work. You could be in management, you could be in software, you could be in hardware, you could be in projects, you could be working with the utilities, you could be working in microelectronics. There are many opportunities and it will be a very fulfilling and rewarding career. The development of electrical technology is for your generation, and we'll be delighted to meet you here in Manchester and hope that you can join one of our programmes.